All right, number 3 and 4. Again, this is chapter 6-3, 6.3. So we'll start off. This one you'll notice is a cube root. So it is an odd root, therefore it is not an endpoint, it is an inflection point. All right? And just like before, we get that inflection point just like we get the endpoint. So this one is at -2, 0. All right? -2. Remember, everything inside is backwards. Nothing is being added, so it's like having a +0 out there. All right? And for my graph, I'm going to put it in the middle. All right, because if you remember, these go both directions. That's an inflection point, so it heads off in both directions. So as I stick this in my graph, and again, it's easier to write this, instead of a root, it's easier to write it as to the 1/3. All right, it's just easier. It's easier than figure out how to deal with that. So 2 times x plus 3 x plus 2. I'm sorry, close parentheses. To the 1 divided by 3. And I'll go to my table. And if you scroll up to -2, 0, you'll find you've got a -3, -2. Oop, get the right pen. My 2 back. -3, -2. You have a -1, 2. And if I scroll that way, I get a -10, -4. And if I scroll this way, I think I get a 6 something. 6, 4, yeah. Cool. So those are my points, right? And this is still my inflection point, that point in the middle. So to graph this, I got to go from -10 to 6. So I need more negatives than positives, so I'll slide it to the right a little bit. And I'm probably going to have to count by 2s. And I go from -4 to 4, so that one's split even. And again, I'm going to count by 2s for my x's. And I'll count by 1s for my y's, because I got to go further with my x's. So 10, -4. 2, 4, 6, 8, 10. That's 10, -1, -2, -3, -4. Okay. -3, -2. That's 2, 4. So -3 is in the middle. -1, -2. -2, 0. Well, there you go. -1, +2. Well, that's in the middle there. +1, +2. And 6, 4. Oh, come on. There we go. 2, 4, 6, 1, 2, 3, 4. So this one looks like this. There's that inflection point in the middle where it goes straight up for a brief instant. And that's what it looks like. It looks like a lightning bolt or a snake. There's a snake in my boot. Now, the domain and range. Okay, it goes left forever and it goes right forever. So the domain is all real numbers. The range, well, it goes down forever, and it goes up forever. And it's, again, all real numbers. Now, if you want to write -infinity to +infinity, that is more than fine. If that's how you want to remember it, I'm not sweating it. All right. Number 4, go ahead and try it. Take a break, pause the video, and try number 4. All right. So, again, we have another odd root. We have an odd root. So this does not have an end point, it has an inflection point. Remember, even is the end, E goes with end, odd goes with inflection. And the inflection point for this one is 0, 1. All right? Because there is nothing being added on the inside, so the x value is 0. And there's a 1 being added on the outside. So again, I'll put it in the middle, 0, 1. And this one's a little strange. So I got -4, 3. And I probably have +4, -3. +4, -1. Well, that's interesting. 4, -1. That's interesting. Okay. The next one is probably way out there. Yeah, it's at -32, 5. So you know what? I'm not going to do that one. This is a good little chunking. So here we go. I got -4, 3. 1, 2, 3, 4, 1, 2, 3. I got 0, 1. And I got 4, -1. So this graph, and if it helps you actually look at the graph to get an idea of what it better looks like, since you've got a calculator, might as well hit graph. This one comes in from the right, slowly curves up, levels off, and then heads back out like that. So it's just like number 3, except squished a bit and flipped. It's reflected across the x-axis, is the technical way of putting it. And your domain and range are the same. The domain is, again, all real numbers, and the range is, again, all real numbers. Cool? And there you go.